Hi, I'm Andy, and in this video we'll be exploring how to attack, detect and defend against execution guardrails. Most of you will have probably already heard of Stuxnet, the 2010 virus which was successfully able to physically destroy some of the nuclear enrichment centrifuges at the Natanz facility in Iran. It was a highly advanced piece of malware, and the authors went out of their way to try and avoid it being detected. They used execution guardrails to ensure that it would only target machines which exhibited very specific properties. For example, one of the initial stages would not install the next stage of the malware on a host unless a very specific piece of Siemens software was present. And a later stage would only run if very specific hardware devices were present. The use of these execution guardrails meant that Stuxnet could quietly worm its way into infecting its specific target without causing any unnecessary disruption to other systems that could lead to its premature discovery. That didn't quite go to plan, but more on that later. Let's take a hands-on look at another somewhat less formidable piece of malware which also uses execution guardrails. Here's a malicious CryptoLocker PowerShell script taken from the 2018 Sans Holiday Hack CTF. Running it does nothing. That's because the creators of this malware have encoded several execution guardrails to prevent it from cryptolocking files unless it's run on a very particular machine. Here I've built a new victim virtual machine which matches the conditions of the execution guardrails. Running the exact same malware now results in an encrypted documents folder. But this victim is not completely out of luck. In this CTF example, the attackers have a flaw in their code which allows for the crypto key to be recovered. If you're up for the challenge, I really recommend giving this a try yourself. There's a link in the video description, but if you get stuck, you can find the solution in my video walkthrough. This CryptoLocker and Stuxnet both use execution guardrails for the purpose of targeting their payloads at specific victims. But this technique is also sometimes used by less targeted malware as a means of avoiding detection and frustrating security analysts. Most malware samples are analysed by running them inside a virtualized sandbox environment to see what behaviour they exhibit. So, some malware attempts to work out if it's being run inside such a sandbox, and if so, change its behaviour. Some common execution guardrails used for this purpose include looking at hardware devices, as a sandbox will likely have virtual device drivers present, or possibly checking for an empty recent documents list, as most sandboxes are fresh installs and not used by a human. Or simply using a timer to delay any malicious activity for several minutes or hours. The ability to detect execution guardrails is dependent on the programming language used for the malware and the level of effort that an attacker has gone in order to try and conceal their actions. An initial view of the CryptoLocker code is a bit of a mess, but after some reformatting it becomes a little easier to read. Within the main program function, we can identify some if statements which set the execution guardrails for this malware. The first guardrail involves a DNS query to a very specific domain. If this returns any non-null response, then the code hits this return statement and terminates. This replicates the kill switch functionality found in the WannaCry cryptolocking malware, which was also triggered by registering a specific domain name. Next, the malware uses the netstat command to check if the machine currently has any processes listening on port 8080. If so, it also returns out of this function and exits. A later stage of this malware starts a process listening on this port, so this check is essentially designed to verify whether this machine has already been infected, and if so, there's no point in infecting a second time. This section of the code also contains a call to determine the name of the Windows domain that this machine is joined to. It will only proceed if the domain name is Kringle Castle. Otherwise, it will again terminate. And finally, the encryption routine has some additional guardrails to only target files which have the extension .elfdb and only files in the desktop, documents, videos, pictures or music folders of the currently logged on user. Of course, many other factors can be used as guardrails, some of the obvious others being IP addresses, MAC addresses, and serial numbers of hardware devices. So, despite the initial obfuscation, it's been relatively easy for us to detect and determine the execution guardrails in this script. Malicious binary executables are more challenging to deconstruct, requiring the use of a disassembler or decompiler for static analysis, or a sandbox for dynamic analysis. And that's exactly what happened with Stuxnet. It accidentally spread outside of its targeted environment and caused some unrelated systems to blue screen. This led to its discovery and subsequent analysis by antivirus companies. For example, this comprehensive report by Symantec describes the malware's operation in detail, including some of the many execution guardrails it had in place, such as only infecting PLCs of a specific type, and only if a specific communications module is present, and even then, only if further specific types of frequency converters were connected. With a bit of detective work, it was identified that the only systems which matched all of those properties were those residing at the Natanz facility. A more advanced attacker may opt to implement a variant of execution guardrails called environmental keying. This technique involves encrypting the main payload with a key which is unique to the targeted system. This is delivered with a shim which retrieves the selected environmental properties from the current system and tries to decrypt it. This decryption will only produce valid code when run on the intended target. Through this method, defenders can identify which specific property is being used as the environmental key. In this example, it's the serial number of the hard disk, but they have no way of determining the actual value of this property. The only way for defenders to determine what the code does, and give some clue as to the intended target victim, is to undertake a time-consuming brute force search. Hopefully by now you've been able to see that execution guardrails are really not much more than gathering some simple system properties and feeding them into if statements. As such, there really is no practical way to prevent the use of this technique. After all, an attacker who has chosen to include execution guardrails in their malware suggests that it's intended to be highly targeted and stealthy. That probably means that it's less likely to be picked up by antivirus vendors, so a traditional signature-based antivirus solution probably won't be much help from a defensive perspective if you're the targeted victim. But, as always, a more advanced endpoint protection solution may fare better if it undertakes behavioural analysis. That about wraps up this video. If you found it useful, please do give it a like and consider subscribing if you want more of this sort of content. Drop a note in the comments if there's anything you think I've missed around attacking, detecting and defending against execution guardrails, or if you have a good idea of what topic I should cover next. I'll see you next time.